In this video, I will explain prove that del cross H is equal to JC plus dou D by dou T. Initially, we will consider for static electromagnetic fields del cross H is equal to J. Amperes circuit law. Ampere's circuit law for static field in the point form or differential form. Differential form is del cross H is equal to J. There is no dou by dou T term in that equation. Applying divergence on both sides. Divergence on both sides yields del dot del cross H is equal to del dot J. According to vector identities, the divergence of curl of a vector is 0. According to vector identities, the divergence of curl of a vector is 0. That is del cross H is 0, del cross J, del dot J. But the equation of continuity in the point form is the equation of continuity in point form is del dot J is equal to minus dou rho V by dou T. In case of static fields, from the Ampere circuit's law, del dot J is equal to 0. In case of continuity equation, del dot J is equal to minus dou rho V by dou T. These two are not equal. If del dot J is equal to 0 implies that dou rho V by dou T is 0. This is not possible. This is for static fields. This is for time varying derivative. These two are not compatible. For time, del dot consider del dot H is equal to J is only valid if the fields are not time varying. The fields are not time varying. For time varying fields, the law needs some modifications. For time varying, For time varying case, the needs some modifications. In time varying case, del dot h is equal to minus dou v by dou t not equal to 0. Therefore, these two equations are not compatible. Some inconsistency there. From the Ampere's law for static fields, del cross h is equal to j. Del cross h is equal to j. Del dot j is equal to 0. Continuity equation, that means time varying fields. Del dot j is equal to minus dou rho by dou t. These two equations are not compatible. Inconsistency is there. The equations are not the equations are not compatible. For time varying fields. We must modify equation del cross h is equal to j by adding one unknown term, say n bar. For time varying fields case, we must modify equation del cross h is equal to j by adding one unknown term, say n bar. Therefore, del cross h is equal to j bar plus n bar. Again, taking divergence on both sides. Again, taking a divergence on both sides. Del dot del cross h bar del dot j plus del dot n. This is the modifying equation for time varying fields. For static fields, del cross h is equal to j only. Again, this term is equal to 0. That means the divergence of Kerala vector is 0. The divergence of Kerala vector is 0 means del dot del cross h is 0. Del dot j plus del dot n. Del dot n is equal to minus del dot j. Del dot j is equal to minus dou rho v by dou t for time varying fields. Therefore, del dot n is equal to minus of minus dou rho v by dou t. That is equal to dou rho v by dou t del cross n. According to Gauss law, according to Gauss law, del dot d is equal to rho v. Del dot d is equal to rho v. This is rho v. Therefore, del cross n is equal to dou by dou t. The rho v is replaced with del dot d bar. That is equal to del dot dou d bar by dou t. Compare this del dot n is equal to, compare these two. Therefore, n is equal to dou d bar by dou t, dou d bar by dou t. Now we can write Ampere's circuit law. Now we can write Ampere's circuit law. Now we can write Ampere's circuit law. Del cross H is equal to del cross H is equal to J plus N, J bar plus N bar. But N is equal to J bar plus N is equal to dou D bar by dou T. This is equation 1 and this is the first term 1 and the term 2. The first term in equation is conduction current density denoted by Jc. This one is Jc. The first term in equation, the first term in equation is conduction current density denoted by Jc. This current is due to moving of charges. Current is due to this current is due to moving charges. The second term in equation represents current density. Current density expressed in amperes per square. Ampere per square meter. This is also called as JD. Conduction current density, displacement current density. D is called as displacement current density. Displacement current density, JD, that is dou d bar by dou t, dou d bar by dou t. Variation of electric flux density. This is the variation of electric flux density. Electric flux density with respect to time. That means time varying. Therefore, del cross H is equal to conduction current density plus displacement current density JD, where JD is equal to dou d bar by dou t. This is the Maxwell's equation based on Ampere circuits law for a time varying fields. This is Maxwell's equation based on Ampere's circuit law for a time varying fields. For a time varying fields. JC is called as conduction current density due to flow of charge carriers. That is JC is equal to sigma E. The insertion of JD was one of the major contribution of Maxwell's. Without the term JD, electromagnetic waves propagation would not possible. JC is equal to sigma E. Therefore, finally, del cross H is equal to JC plus dou d bar by dou t. This is the Maxwell's equation in point form or a differential form. Maxwell's equation for time varying fields. Maxwell equation for time varying fields in the point form. This is the Maxwell's equation for time varying fields. For time varying fields. Consider this conversion of this time point form into integral form. Point form into integral form. Apply Maxwell equation. Conversion of next. Conversion of differential form of Maxwell's equation to integral form. Del cross H is equal to JC plus dou d by dou t. Take surface integral on both sides. Take surface integral on both sides. Surface del cross H dot ds is equal to dou d by dou t plus jc dot ds. Applying Stokes theorem to LHS. Applying Stokes theorem to LHS. Left hand side term. This surface integral is converted into line integral. That means surface integral del cross H dot ds is equal to line integral H dot del cross H is replaced with H, ds is replaced with dl over line integral L. Therefore, the equation is this one is replaced with this term integral over L H dot dl is equal to surface integral jc plus dou d by dou t dot ds. This is the equation in integral form. Next one, Maxwell's equation for timing fields. Maxwell's equation for free space. For free space. J is equal to 0. For free space, J is equal to 0. Here, first equation here del cross H dot ds is equal to J is equal to 0 means integral of dou d by dou t dot ds. We know that another expression del cross H is equal to Jc plus dou d by dou t. J is equal to 0. Therefore, del cross H is equal to dou t by dou d by dou t. This one is 0. Another equation is line integral over h dot dl is equal to surface integral. Jc is 0. That is dou d by dou t dot ds. Dou d by dou t dot ds. This is for Maxwell equation for free space. Next one, Maxwell's equation for static fields. Maxwell's equation for static fields. For static fields, we know that del cross H is equal to J. Del cross H is equal to J for static fields. Apply surface integral. Surface S del cross H dot ds J dot ds. J dot ds. For static fields, del cross surface integral, applying stroke theorem, surface integral is converted into line integral. Line H dot dl is equal to J dot ds. J dot ds. J dot ds. This is a Maxwell equation for static fields. Maxwell equation for static fields. Here one more important. Here line integral over h dot dl is equal to surface integral jc dot ds plus dou d by dou t. Jc dot ds is I. This one is written as integral over s jc dot ds plus integral over s dou d by dou t dot ds. This one is integral line integral over h dot dl. This term is I. This term is I is equal to integral surface integral over jc dot ds is equal to I. Is equal to I. This is the Maxwell equation for time varying fields. Del cross H is equal to J plus Jc plus dou d by dou t. With this, the analysis is